Hello everybody. Today I'll be solving this interesting integral with complex boundaries. So initially one may believe that a u substitution or integration by parts will work well, but that's wrong because actually you'll just make the integrand much more complicated and we don't want that. So instead the method here to use is actually the dummy variable, which states that if you have an integral of this form with these boundaries, its equivalent form is simply the same integral with the same boundaries but with the different function input value, so we have f a minus x as the difference, dot dx. So what this is saying is that we switch the independent variable x to a minus x, so we substitute everything we see, so all the x's we see here in the initial expression with a minus x. And if you inspect closely, the a here is negative I pi on 2. So what we can do now is we can write an equivalent integral. We will denote this as I1, the initial one, and the other one, the equivalent one, as I2, which is simply equal to 0 negative I pi on 2 natural log e to the power of now negative I pi on 2 minus x, utilizing the dummy variable, minus e to the power of negative I pi on 2 minus x, all over e to the power of negative I pi on 2 minus x plus e to the power of negative I pi on 2 minus x bracket dx, And what I'm going to do is I'm going to try and simplify these using exponential laws, So the next step here is simply writing the integral. And now I'm going to use my exponential multiplication law. So I'm just going to rewrite this as e to the power of negative I pi on 2 times e to the power of negative x, Negative minus e to the power of I pi on 2 times e to the power of x, because if you inspect here, these negative signs just cancel out, Simple algebra. All over e to the power of negative I pi on 2 times e to the power of negative x plus e to the power of I pi on 2 e to the power of x bracket dx, And then the next step I do here is utilize two important facts using Euler's formula. So if you're unaware of Euler's formula, that's okay. It's just basically a formula which Euler, this famous mathematician, made, which relates the exponential function to complex numbers through trigonometric functions, So what we need to know here, it's important, it's okay if you don't know it now, is that e raised to the power of I pi over 2 is equal to I, and e negative I pi on 2 is equal to negative I. And I can make a future video explaining this here, So what this basically implies is that this integral is equal to 0, negative I pi on 2, natural log. Now, remember e to the power of negative I pi on 2 is just simply negative I, where I is equal to the square root of negative 1 if I haven't mentioned yet. So negative I times e to the power of negative x, negative I e to the power of x, all over negative I to the power of e negative x, multiplied by e to the power of negative x, plus I e x, bracket dx, And the next step I'm going to do here is I'm going to factor out the i's, the imaginary units, and this will just simply obtain 0 to negative I by 2 ln e to the power of negative x plus e to the power of x, or over e to the power of negative x minus e to the power of x, So I just factored out the negative i's, dx. So now this is what our equivalent integral looks like, I2. However, note that I1 is equal to I2, right? It's the dummy variable. They're the same integrals, but in different equivalent forms, okay? So we could simply just state that 2I, right, is equal to integral from 0 to negative I pi on 2 ln basically the initial integral here. So that's just simply e to the power of x minus e to the power of negative x all over e to the power of x plus e minus x dx plus what we just found using the dummy variable plus this integral over here, which by the way is the same integral, 0 negative I pi on 2 ln e to the power of negative x plus ex all over e negative x negative ex. And in case you need a refresh on your logarithm laws, the addition of two logarithms using logarithmic laws, so ln a plus ln b is equal to logarithm ab. Okay, so this is an important factor we need to use. So this just simply becomes equal to 0 negative I pi 2. And also an important fact, notice how we can add these logarithms because they have the same boundaries and they're integrating with respect to the same variable x, okay? That's also another important fact. So this is equal to the integral from 0 to negative I pi on 2 logarithm initial e to the power of x minus e negative x all over ex plus e minus x times by, right? Times by this part here, this component here, e negative x plus e to the power of x all over e to the power of negative x negative e x dx. Okay. However, what is this equal to, right? What is this equal to? This is just simply 0 negative I pi on 2 ln negative 1. Okay. All right. If you reverse the sign of this, you would simply get this. Okay. So we have 1, 2, right? Simply, if you want to check for yourself, 1 is just simply to negative 2. Okay. So simply if they multiply each other, right, it would just be negative 1, and then it would be the natural log of negative 1 times, by the way, dx. So what is ln negative 1? Ln negative 1 is a constant, okay? There is no independent variable x in the expression ln negative 1, so we can just take it out of the integral. So 2I is just simply equal to ln negative 1 dot 0 negative I pi on 2 1 dot dx, okay? And actually, negative 1 in this scenario is e to the power of negative I pi, so this is just equal to ln e to the power of negative I pi times by from x, evaluating from x, because notice how this has boundaries here, from 0 to pi onto negative I pi onto. And using our exponential laws, we can just take the negative I pi down below, and then the logarithm, the natural log of e is obviously 1. So this is just equal to, the natural log of negative 1 is I pi plus I pi, not negative I pi, okay? Just a mistake. So this is just equal to I pi multiplied by negative I pi on 2, okay? Is equal to pi squared on 2, okay? So now we finally found our answer, although that's not quite right. We found the answer to 2I, okay? We want to find I. So simply, therefore, the integral is just simply half of what we found. So it's just pi squared over 4, okay? So yeah, that's just our integral, and this is our answer. So yeah, that about completes it today. So yeah, what we did here first was use the dummy variable, then we did some algebraic manipulation, and then we found the equivalent integral form, and then we deduced that 2I is just equal to this over here, and then yeah, we utilized many different laws here. So we used dummy variable, right? We used the addition of logarithms, we used exponential laws, right? We used Euler's formula or just for just one integral. So yeah, I hope you were able to follow along. And please like and subscribe for future videos. Sorry if this one's a bit poor quality. This is my first video. But yeah, I hope you enjoyed today's content. Thank you.